Hi, today I'll begin introducing you to many of the most common math problem types that appear on exams like the SAT, GRE, and GMAT. Our lesson for today will be in probability.
I'm Ari, I'm a sophomore at Gateway High School, and before I came to David, I was really struggling in my geometry and my algebra class. I was getting really low grades on all my tests and was not understanding any of the homework. Now that I've been working with David for 2 years, he's really helped me understand all the concepts and be able to achieve much higher grades on my test and complete all the homework. David has not only helped me complete my work, but also understand it, and he's really turned my academic career around.
Hi, the topic today is probability, which is a common math topic on exams like the SAT, GRE, or GMAT. The first thing you need to know is the basic definition of probability. Let's take a look. In a class of 4 boys and 6 girls, a student is chosen at random. What is the probability that a boy is chosen? Use your basic definition. There are 4 boys. That's the number of ways of choosing a boy. And then if there are 4 boys and 6 girls, that gives you 4 plus 6 total outcomes, which would mean 4 out of 10, which could be reduced to 2/5. Here's another problem that can be solved using the basic definition of probability. Let's take a look. 2 fair dice with sides numbered 1 through 6 are rolled. What is the probability of the same number appearing face up on both dice? So the first thing you want to do is count up the number of ways that this could happen. You could have a 1 on both dice. You could have a 2, 2 on both dice, 3, 3, 4, 4, 5, 5, or 6, 6. If you counted that up, you'd see there's 1, 2, 3, 4, 5, 6 ways to get the same number appearing face up on both dice. The denominator will be the total number of possible outcomes. If you have 6 choices for die 1 and 6 choices for die 2, there would be 6 times 6 or 36 possible outcomes for the 2 dice rolled together. Your answer would become 6 out of 36, which could be reduced as a fraction to 1/6. Hi, many challenging probability questions can be solved by taking a fill-in-the-blank approach. 5 different classes are to be taught on 5 consecutive days, 1 class per day. How many different orderings of these classes are possible? Many students will see this and say, oh, 5 times 5, 25, and they'll get kind of stuck there, but that's not the answer. Here's maybe a better way of thinking of it. Draw out 5 blanks to represent, let's say, the 5 days of the week. Monday, Tuesday, Wednesday, Thursday, Fridays. And over here you've got your 5 course offerings. Algebra, Bio, Chem, D, and English. On Monday, you can choose any of these 5 classes for Monday's offering. So you have 5 choices for the first day. Now let's say you teach Bio on Monday. You're not going to teach it again on Tuesday, so cross it off the list and you're down to 1, 2, 3, 4 choices for Tuesday's class. On Wednesday, you'll be down to 3 choices, Thursday 2, and finally on Friday you only have 1 choice of class left to teach. The basic counting principle says that from there, simply multiply those numbers to get the total number of combinations. 5 times 4 is 20, times 6 would be 120 different orderings of the classes. Here's another tough GRE, SAT, ACT, or GMAT probability question that could be solved by taking a fill-in-the-blank approach. Let's take a look. How many 3-digit integers have an odd first digit and an even last digit? So your first step is to kind of think about what the question even meant, and can we think of any numbers that would fit that description, such as 582 or 794. Both of these numbers have an odd first digit and an even last digit. Now we hate to have to list them all out, so let's just draw 3 blanks to imagine the 3 digits of the number. And the odd single digits are 1, 3, 5, 7, and 9. Therefore, for the first digit of our number in question, we had 5 choices. Now let's take a look at the last digit of the number, which was meant to be an even digit. And of course, the even digits are 0, 2, 4, 6, and 8. And of course, there's 5 of those also. And so there would be 5 choices for the last digit. Sometimes people forget about that middle digit, but there'll be 10 choices there because there were no restrictions on the middle digit. Could have been any of the 5, odd or even. In other words, any of the 10 digits in our base 10 system. Finally, the basic counting principle simply says multiply the number of choices at each step of the way. Therefore, our answer will be 5 times 10 times 5, 50 times 5, or 250 total 3-digit integers. Our next problem illustrates a useful rule, the idea that the word "and" in probability lets you know to multiply the probabilities. "And" tells you to multiply. Let's take a look. 4 fair coins are tossed. What is the probability that all 4 land heads up? So if you flipped a coin before, you know that there's equal probability of getting a head or a tail face up. The probability that each coin lands heads up is 1/2. However, if you want the first coin to land heads up, and the second coin to land heads up, and the third coin to land heads up, and the fourth, it would be 1/2 each time, all multiplied out. We could then multiply these fractions by 1 times 1 times 1 times 1 on top, and 2 times 2 times 2 times 2 on the bottom. That would give you 4, 8, 16. There's a 1 in 16 probability that all 4 coins land heads up. Let's take a look at one more probability question. A jar contains 30 red and 50 blue marbles and no other marbles. How many red must be added to the jar so that the probability of selecting a red marble is 3/4? So if you remember your definition, you recall that the probability of selecting a red marble is like the number of red over the total. At the beginning of the question, there's 30 red, and there's 30 plus 50, or 80 total marbles. Now normally I'd say, oh, cross out the 0 and reduce to 3/8. This is the one time you won't do that, because we're about to add some marbles to the jar. We don't know how many, so let's add X red marbles. And the key inference is that's also going to add X to the total number of marbles in the jar. And after doing all that, the resulting proportion is meant to equal the probability of selecting a red, namely 3/4. From there, you can solve by using the cross-multiplying method. Hopefully you've seen that before. It says to multiply along the diagonal 3 times 80 plus X, and on the other side 4 times 30 plus X. Don't forget your distributive property. 3 times 80, 240, plus 3 times X equals 4 times 30, or 120. Distributing the 4, 4x. From there, it's relatively easy to subtract 120 from both sides so you can combine your like terms, and subtract 3x from both sides to get the x's together on the right, and you'll have 240 minus 120, or 120 on the left. The x's cancel out, and you'll have 4x minus 3x, or 1x on the right. And there was our answer. 1x is 120. We'd add 120 marbles to the jar. Let's check it. 120 plus 30 would give us 150 red marbles. 120 plus 80 would give us 200 total marbles in the jar. Type it into your calculator and you will see that it does in fact reduce to the desired probability of 3/4. Thanks for joining me. If you're already logged into a Tutor Talk classroom, please try these next few problems on your own. If you're not, come and visit me on www.tutortalk.org. Hit contact us and write me an email and I'll set your lesson right up and you can learn more about probability and practice right along with me or another live tutor. If you happen to live in San Francisco, Bay Area, and want to work with me personally, look me up right here at noevalleytutor.com. Thanks so much.